Okay, let's move to the next topic from the governing board chair Rolf Dach from University of Bern. The topic is again the ESA Genesis mission implementations for IGS GNSS analyze.
Yeah, in that case, thank you for the introduction, but I don't stand here as the governing board chair, but as the chair of the working group 2 that was established by ESA as interface to the scientific community. In this working group I am chairing together with Benjamin Mennel. So, and I want to now derive from the information that we have so far on the Genesis mission. What does it mean for the IGS? We have a crucial role in this mission, and let's start with the question what Genesis is. For the old guys like me, this is a music band. For the younger people, it might be a car, but as we just learned, it's a satellite. And Francesco has just shown it. The GNSS devices are these two. Oh, yeah. No. So are these two antennas? Francesco has shown it. I don't need the pointer for this. The data from these two antennas go into one receiver that was just introduced by Francesco. And we have exactly one receiver. There is no redundancy there. And this receiver is capable to track Galileo and GPS, as Francesco has just pointed out. 2 years ago, we asked which analysis centers are interested to process Genesis data, and we got a reasonable number of analysis centers with positive answers. So it means then you need to process GNSS data with two Rhinix files, one from the Chinese, one for the nadir antenna, that should point to one position. What about the hardware delays when you have the cable from the zenith and nadir antenna into the box? It's not clear yet how stable this is. In the best case, it's an offset. In the worst case, it's something which is temperature dependent, and so from this, depending how the orbit is pointing towards the sun. You have seen the design of the satellite. So to build a satellite that you would like for orbit modeling, it would look a bit different, but we will have to live with it, how it looks like. So from this, let's see it as a challenge to those analysis centers that are going to process the data. The developments of Genesis have also some opportunities for the IGS. One is that it has pushed some more pressure or enabled approaches like COOL, or what we have seen from Athena, to make a pre-combination. When the IRS combination centers are not happy with combining 20 solutions into an ITRF, we need the opportunity to combine the orbits from LEOs together with the station coordinates and other parameters. And those made their great effort to develop an algorithm to combine orbits on normal equation level. And he just told me next week we will get a call for participation for prototype phase of this. Possibly it might be a week later. This exchange will take place on Zynex format. It means that we will need to adjust the Zynex format, and it has unfortunately also some consequences on the combination of the products. But it has also the chance for us to introduce LEO orbits from not Genesis orbits into the Zynex files and combine them. Okay. When we look at this configuration of this satellite in 6,000 kilometers high, then we are tracking the GNSS satellites at nadir angles where they are not designed for. So we see here the nadir angle for the GNSS satellite goes up to 30 degrees for Galileo and for GPS. What we have so far ends at approximately 20 degrees. So that's why this working group has made a request via ESA to Galileo that we get an extension of the Galileo satellite antenna pattern up to 30 degrees. At least Pierre Vallée did confirm that is under processing, even if we haven't seen it so far. But I'm quite convinced that one of the 1,000 jobs that he has is to bring this forward. We don't have this direct connection to GPS that we can ask them, but we have from the 3A satellites manufacturer values, and from the 2F satellites, we have found some pattern that have been calibrated at Lockheed Martin, and Oliver made therefore in a publication 2023, sorry, this is missing here, to make them compatible with the reference frame. But how to use this? We have our pattern that we have estimated up to 14 degrees. And then comes something independent. Do we want to have an interrupt there? Or do we change to this pattern? A question to be answered within the IGS community. So it means at the end, we need to think about whether we want to change before Genesis is launched, before we at least process Genesis data to this new antenna model. What is then the impact on the products when we are changing this model? Another issue related to the stuff what Francesco has shown are the signals that we can get from this GNSS receiver. So I'm already one step further in thinking than Francesco was, because the IGS network is using L1 and L2 for its ground stations. That's why we have also requested that this space PNT receiver learns what GPS L2 is. And that's why I think the mandatory frequencies for GPS is L1, L2. At least when we look at our ground network to get compatible to the history of the GNSS data there. But if the receiver is able to track L5, why not to use it? But as we also just learned from Francesco, this is not for free. We have only 64 channels. Either we just track 32 satellites with 2 frequencies, or with 3 frequencies, you only get 21 satellites. So in theory, you can observe about 40 satellites, as Christoph has pointed out. But if you look at link budget and some electronically visible satellites, you are about at 30 satellites. But we would lose about a third if we ask for the third frequency for GPS. From this, there is one point, of course. It would be nice if a reference frame in 2015 is potentially based on L1, L5 GPS, then it would be great if those guys can still use Genesis. But from this comes the question to the IGS, what are the plans with L5? Do we continue to ignore it? Or what to do? Something which triggers as well the discussion is a statement from the GPS system that makes the announcement, so it's as usual small text, but the key message is when there are 24 operational satellites that emit L5, 2 years later they will switch off the PY signals on L1, L2. So looking at the current constellation, we are at 21. So 3 satellites are still missing to achieve this 24. Assuming next year they launch the first 3 F satellites, it might take a year in orbit validation, but at 2030 we have this 24 satellites, 32, then we don't have PY anymore. For the IGS, it means that we need to redefine our reference for the clocks, because this is at the moment the ionospheric free linear combination of these encrypted signals. So we have to do something. How to organize this and how far we want to go when we know we could switch to L1, L2C, but all the other systems, Galileo, Beidou, have signals on L1 and L5. This would be much cooler for the antenna calibrations. How far we want to go. And depending on this answer, of course, comes also then the question what to do for Genesis. Do we need to go for 3 signals with GPS? Or in the worst case, to ask ESA to have an option that we can switch at the day X for GPS from L1 to L2? Not sure what does it mean at the end. From this, we need this answer in not too far future. Fortunately, we are meeting here in Santiago that we can discuss some of these questions. So it means this challenging orbit modeling, this is something which we can solve together with this IAG working group that is existing and working on it in the context of Genesis. I hope that a number of ACs will answer this call for participation for design extension. Something what we need to discuss before we can process the Genesis data is how to handle this extension of the pattern of the L3 of the up to the 30-degree Nete angle. I was discussing this with Arturo, and we will discuss it in the antenna calibration meeting. What is the future of GPS L5 in the context of GPS? Something what is an item in discussion on Thursday in the splinter meeting of the AC. That's all what I have. Please join the meetings to take part in the discussion. Thanks.